Hello students, welcome to this video. This video we're going to go over question 20 from chapter 2. So this is right from, let's actually go into question 20. Here is the question. There's question 20. Solve the following linear program model graphically. We have the objective function, its maximization. We have 3 constraints, and then the non-negativity constraint as well. So this is a question right from our book. I've drawn this out. There's an objective function. Let's put in, where is my pen? We should have this noted in here just so it's easier to understand what we're doing. Try to maximize the objective function. So 1x plus 1.5x1 plus 1x2, there is the value. So we drew this out. Now the first 2 constraints, there's only one variable. So x1 is less than 4. So the boundary is that when x1 equals 4. So basically it's on the left side of this line here. x2 is less than 6. Has to be less than that horizontal constraint, and then constraint 3, x1 plus x2 equals 5, so the sum of x1 and x2 has to be 5, so we set both at 5, and there is the maximum boundary. There's 3 points here, A, B, and C. It does not look like constraint 2 is needed because it's not defining the boundary, the blue shaded in region. It's not defining that, it's not helping to reduce it. So let's look at these 4 points here. I'm just going to erase this so I can have a little bit more room. And let's go with red. For point A, we know that x1 equals 0 and x2 equals 5. So z here would be 1.5x1, which is 1.5 times 0 is 0 plus 1x2. So z is 5. At point C, we know that x1 equals 4. x2 equals 0. So z here would be 1.5 times 4 plus 1 times 0. So 1.5 times 4 is 6. So point C is better than point A if we're trying to maximize profits. Point B, though, we need to know the intersection of point B, which is easier than we've done before because it's the intersection of our first constraint and our third constraint. So our first constraint says x1 at that boundary point equals 4. It's less than or equal to 4. We are right on that boundary line, so x1 equals 4. If that's the case, then when we put that value into the second constraint, which is x1 plus x2 equals 5, we've got 4 plus x2 equals 5, x2 equals 1. So at this point, z is going to equal 1.5 times 4 plus 1 times the value of x2, which is 1. So 1.5 times 4 is 6 plus 1 equals 7. So where is the optimal solution, I should say? It's going to be at point B. Point B is what we should produce. We should produce 4x1 and 1x2. If we do that, we will maximize our profit.